Hello and welcome to Science Visualized. Today we are looking at a reaction mechanism of the reaction between alkene and hydrogen halide, in this case hydrogen bromide. And we're going to use this alkene here plus hydrogen bromide. What you get is a Markovnikov addition. You get a Markovnikov addition of H and Br. That means H adds to the carbon with the most hydrogen, which is this position here, while the halogen group, in this case the bromide, adds to the carbon with less hydrogen. Now, mechanism. This reaction goes through two steps. In the first step, the alkene acts as a nucleophile because it has a higher electron density, and therefore you get the alkene attacking the proton on the HBr, which will be an electrophile. So E plus for electrophile, while the alkene is a nucleophile. I'll use Nu minus for nucleophile. At the same time, you break the hydrogen-bromine bond and the electrons flow to bromine to form a bromide ion, or Br minus. Now you have the hydrogen adding to the carbon with the most hydrogen following Markovnikov addition. But look at what happens at the other carbon, this position. After the electrons are used to form a bond with this proton, you end up with nothing adding to that carbon, and therefore that becomes empty. We put a formal positive charge there, and that's called a carbocation. So this is called a carbocation intermediate. And therefore, in step 1, what you end up with is the formation of the carbocation intermediate. And I'll use this as an abbreviation for carbocation, C with a plus. I forgot to add this. You form a carbocation intermediate and a bromide ion. Now let's go to step 2. In step 2, you bring both of these two groups, the carbocation intermediate and the bromide ion, and use them as the starting material for step 2. So with the bromide ion. Now you can clearly see that the bromide ion has a higher electron density, so that becomes a nucleophile for step 2, while the carbocation carbon has low electron density, so that becomes the electrophile for step 2. So basically what happens in step 2 is that the nucleophile, the bromide ion, attacks the carbocation intermediate. Always you draw the arrow in such a way that the head of the arrow, so the head of the arrow faces the electrophile position, while the tail of the arrow always points to the electron-rich species, so where you have higher electron density. Look at step 1. The higher electron density, the tail of the arrow, was pointing to the alkene, while the head of the arrow was pointing to the electrophile, which is the proton. Then this gives, we still have the blue hydrogen attached to that position, but now after step 2, we end up with the halogen, in this case the bromine, added to that position. And that's the end of the mechanism. It has 2 steps. Remember the H bromide used in this position, you can also use HCl or HI. So we generally abbreviate this as HX. Thank you.